Assalamu alaikum again. Um, you remember I said the last video that Excel has some limitations. So I would like to show you how it can be done, how to find the origin time using actually a programming language like Python. You don't need to follow the same steps I'm doing. This is just general information. You even don't need to watch these videos if you're not interested. But basically, how it can be done, I will be showing you in simple way. So before doing anything in Python, there are some applications or some modules we need to bring. Um, so the first one I bring is called Pandas, short Pandas as PD. So PD is a shortcut. I will be using PD instead of the full name Panda. I will import a plotting package also called matplotlib. Import matplotlib.pyplot as plt and import something which deals with times in Python. Import date time as dt. I make it a shortcut. And also from MATLAB, I need to import some packages which can play uh, with dates. Imports, the first one, date, date to number, and the second one is data formatter, data format, date formatter. Yep. And let's import also NumPy. NumPy is important package for numerical analysis. NumPy as NumPy. So let's make some data right now. Here I'm clicking Shift Enter to move from one cell to another cell. The simple way to make data, I prefer always to use pandas. So I name my data, it's like an Excel sheet, data frame. df data frame equals pd.data frame, and I basically open brackets, and inside that bracket I make some columns or some data. The first data or the first column is date time of t. It's gonna be, let me copy the same one I showed you in the Excel sheet. I have them in the Excel. I will just copy them one by one or copy them all once. This thing in Python is a list. They call this thing a list. A list is simply a container of some data. So in this case, it's containing four data points. All of these data are strings. So this is a string. Khalil, that's string. This is a string. Those are also string. Anything between single brackets or single brackets or double notations, that's what we call a string in Python. And after a dash, I bring another data that I name it s minus p. This is gonna be simply some numbers. So I bring the same numbers I showed you in the last video, copy them, the Excel, here they are. And I simply click run. If you want to see how the data looks like, this is the data date time of P, and that's the difference between S and P. And if we want to check what is the data types in this data frame D types, it tells me that this is a float. Float is simply like a number with fractions. 1, 2, 3, they are whole numbers. We name them integers. But 1.3, 1 point something, those are fractional numbers or floating numbers. these are floats. Object are strings. Usually strings are objects, but you don't need to care. So one important thing is to convert these things, these values, this object to date time, to objects that are actually representative of real date time in Python. And I can do it simply by converting this date time of P to real date time, and apply some function to it. Apply, the function name is lambda, name it, this is anonymous function, lambda x equal date time, date time. This is the module I imported here. This module actually can convert these strings to real date times. They are strings right now. Computer assumes they are strings, and I'm trying to convert them to real date times. So that's a function within date time. It's called strip a date time. I choose this one and I convert this one x to simply something called y. You make this y small or capital based on the value you have in the year. If it's just two numbers, you make it small. Then month. So this dash is this format I have. A percent is the formatting of the value. This is month, then another dash, a percent, then D, then there is a space. There is a space between these two, and uh, then I have percent H hour, then a percent minute, capital, then a percent second, and they also need fractions of seconds, fractions, so small fractions. So that's it. There are a lot of different formats you can apply to your date times. If you have such date time, you probably just take this one, but if you go to Google search how to format dates, how to convert dates from string to real date times, you'll find many different sites guiding you through this conversion. So I just click enter. This time not apply to TRT. Oh, sorry, I forgot this one. This is trip time. Yes. So let me check the date time. You'll find it's the same as the previous one, but if I go check the data types, right now it's date time object instead of normal object as before. Uh, the next step is to create some random dates, range of dates. So let's create some random dates with some specific interval. The first date I make it base date, and I use again the same function date time. This function, if you go to the help, you'll find it accepts year, month, day, minute, seconds, microseconds even. Whereas in Excel, you cannot go beyond seconds. It goes even to nanoseconds and even time zone. So what's the time zone, for example, in Muscat or in any other region in the world? So we say 2005, and let's make it fifth because that's fifth, 11th, 15, and the hour is 15, And the minutes, let's make it 8. So we start from this time, we go forward by some increments. In Python, there is something called list comprehension. I will do that list comprehension right now. So it starts from base time plus dt time delta. I'm creating delta time and I go by seconds. Seconds equal x, where x in a range. So in how many seconds we want to go? So in in 1 minute there are 60 seconds, but I want to go, let's say 5 minutes. That's fine. So let's make it 5 minutes. And I click run. So if you check this one, this is actually a long number. Starting 8 minutes, 8 and 1 second, 8 and 2 seconds, and so forth. So it goes how many, as we said, 5 minutes. Goes almost to 13 minutes. 15 and 13, close to 1 second is left to 13, according what we stated. The last tip, we have our data. Let's make some plotting. So how we make plot? First, let's define a figure. Figure, and I give it a random size. Fig size equal, let's say 8 by 5 inches. We run it first. Almost mistype. Figure. So still there is nothing. What gonna be the x-axis? X-axis gonna be date to number. Did, did I bring this one? That's the date number. I convert my dates because whenever you want to plot something, you first need to convert it to number data frame, and I select the the t time data frame. Let me repeat instead of typing. And the y-axis gonna be data frame s minus p. Still nothing. So if you want to plot it right now, we can do plt dot plot x-axis against y-axis, and let's give it a label يساوي and name it original data. This is my data. So these are the data, but we will go for that, but because let's scatter. So these are the data, but I want to make a fit along them. For the timing, let's convert it back to plot because I want to show you another thing. Uh, make let's show the schedule because I want to explain in here. I want to fit a line similar what to I have done in Excel. How it can be done? There are some functions, so they are actually available in NumPy. Let me use them and make it here. So I name a variable, name it linear fit equal numpy dot poly poly fit. That's the function name. Date date to number, and again the same value. Bring it here because I want to make a fitting between these two, between the x and the y. The y is this one. It's very important to convert the time to numbers. If you check the help of this, you'll find it asks for a degree. It's a fit of degree 1. It's a linear fit, so it's supposed to be 1. Here I am just in my Windows. If you are using Windows system, I'm clicking Shift and Tab to get the help. So I got my function. At this function, I want to make a lot of points. So if I run this function, you find just um, it's a function of a line actually. This is the slope, this is the intercept. So this is the slope, and that's the intercept. You can use this function to make a, a line, many points. I make a line instead of just. So that's the best fit. That's the slope of this line, and this is the intercept, y-intercept. How it can be done, there is another function called poly, numpy poly 1D, 1D polynomial, straight line polynomial. Mm, Here, name it linear function because polynomial 1D is a linear function by poly 1D, and you will find that's asking for a function. So this is my function. It's a fun asking for a function. This is C or R. It is one-dimensional polynomial. It's asking for the slope and intercept. Uh, that's how is it. But I provided with some values. So those values gonna be these dates. But I need first to convert them. Date to num data list. That's how is it. Let's change this to plot because my second plot then is what is uh, is actually this times with this one, these two, and I show it here. Actually, there is another function plot date. That's better actually. Oh yeah. So it's already plotting dates. That's what I forgot. I was using plot, normal plot. In Matplotlib, this is the application which I imported here. It has the name Matplotlib, but I made a shortcut name for it and I named it just PLT. This is the convention actually. It's not just used by me. Many scientists are using uh, this convention. And the convention they use for NumPy is MP. For pandas, the convention is PD. So I have this plot. Let me make the other plots. So the other plot is plt.plot data list against what? Linear function. Let's see how it looks like. Somehow good. At least I arrived to some point. But let's cut this one Let's make some data ranges instead of plotting all of this line. You know why it's very long? It's long because the data range is long. The start and end time is very, very long. But I can do many things. First of the things I can do with plotting is show the grid, and alpha is alpha equal 0.5, and the line style is make it a dashed line. So how I can explain this one? So if I make it this one, alpha 1 means they are really strong. If I make it 0, the it will disappear. The the grid lines will disappear. So let's make it something in between. The minimum is 0 and the maximum is 1. That's good. Let's give it a title, plt dot title, and I name it region time. And let's also change the font size. Font size equal 18. Yeah, there is always, if you want to this get rid of this one, just type plot show. Without this one, yeah, the last thing will be outputted in the cell. So I will activate plt.x label equals what? P wave travel time, and font size, let's make it something like 16. Font, yeah, spelling error. plt.y label, let's rename this s minus p travel times, and again font size, make it 16. And let's play around with y limit. So y, I need 0 basically, and I think I don't need 20. So let's check this one. plt dot y lim. That's how simple is it. And you give it the range 0 to 20, 0 to 10. There's no point above 10, so let's make it 10. That's better. Let's decide uh, the X range from where to where. X range, they are in time, so I need first to convert them to numbers using the same function. So let me write this variable X range, and this is the minimum value equals date to num, and I use the same I use this module, which is really amazing module to deal with times, date and times. It's one of the best. So I use the same one again, create a date time, and say how much I wanted. I wanted 2005, 5. This is the same. 15, 10, 15, 10. Yeah, that's 0. This is the minimum. Copy one, save some time. This Rename this one, make it max. Here I want the maximum, and the maximum, let's say it's 11. Is 11, 10, 11, 12. Let's say 11:30, 11 and 30 seconds. Let's see how it looks like. But first we need to apply them. plt.xlim, and this is the minimum value. Ah, the other one is the maximum value. Yeah, I think I can make it even shorter. So this is 30, 10:30. Let's make this one 10:30. And this one I can make it 11:10. 11 and 10. This is 10:30. I think it's gonna be better. Yeah, this is amazing. So this is your origin time. This is better than what you get in Excel, I think. But let me do some more. Let me draw our plot instead of just the time. I I can even plot all the time, all the day even, day and time. Python is really powerful. So let's make this thing. I create a formatter. I format my date, and I use this function I brought from Matplotlib, data formatter. Uh, date date formatter, and I say I need this formatting. So year capital because there's four numbers. Then there is this dash and um, month again. Oops, sorry. This is day and make a spacing hour, minute, and second capital. And I apply this one to the y-axis. How I can apply this one to the y-axis? As how is it? PLT get current axis. I get my axis, and that's the x-axis. Axis set major formatter, and I give it this formatter. Ah, good, but can I make a rotation? Yes, you can do a rotation. So let me rotate them. Let me rotate these labels, tick labels. PLT again, get current axis, x-axis, stick, 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 arms, arms. There is an option rotation equal, let's say 90 probably, and label size, make it higher level. Oh, let's check that without changing. Get current axis. This is a function actually. Yeah, let's increase the label size, make it 12. Copy paste is better. Let's make the legend. This is the original data. Is label best fit. I name it best fit line. You can show the legend simply doing plt legend, and you'll find the legend here. I think this is easy. You want to save it, plt save fig, and give it whatever name you like uh, iPlot, PDF, or whatever format you like. It will be saved in the directory you opened this notebook. That's how is it. If you don't want to save it, you just can even open any snipping tool, just copy it. However, we are interested on this time. Again, those data points, they are dummy data points. They are not real data points. Sorry if my voice, sorry, is not good. Um, I wasn't feeling good the last 3 or 4 days. Anyway, I hope you enjoyed what I did. I received some questions from students asking how this can be done. I first tried to do it in Excel, but surprised that I cannot manipulate fractions. So I decided why not open Python and see how it can be done in Python. And that's how I did. I think to me, not easy, but quite interesting. And it's really powerful. It's really, really super powerful. I can extend it even, get what is this value without me guessing. But yeah, I think this is just enough for you right now. I don't want to make it much longer.